things that can be on the test tomorrow. What is in chapter 4? That's the
Everything on the
chapter we just did,
document.
right? What?
Everything on the document.
Okay, swell.
Right?
Topics wise, what topics are on the test?
Related rates.
Linearization.
Related rates.
What do you want
I am not on the test. What? Mean value theorem. What?
You, I'm just agreeing with you, looking back at once. Of course.
That's it? Okay. Walter, what was that?
Second derivative and like concavity and stuff.
Okay. And somebody said, knowing if the max and the min is absolute versus just local, you need to check the ends and like actually go to the function itself and get their y values. Inflection points.
Do we get a calculator like a four-function one?
You can use a calculator, I don't care.
Any
Can we use our calculator?
You can't use my calculator. If you have the TI-89, you are not allowed
So
to.
no Jesus, but
83,
normal.
fine. 89, no.
No, you're not.
So knowing what critical points are, what inflection points are. Yeah. And then things like this question that I'm asking here. If I want to approximate the cubed root of x without a calculator, because believe it or not, people used to do that. Why? Because they do. So cubed root of x looks like that. It's asking you to use linearization, which means find a tangent line. What x value do you think we should create the tangent line at? 9 or 8? Which one? Oh, 8. Why? Oh, 8.
Because that was a little silly. Well, because 8 is a perfect cube root.
So we're going to find the tangent line at 8 because that's one that I know f of 8 is 8 to the 1/3. Eric's saying, oh, yeah, I know what that value is. What times itself 3 times? That's 8. Isaiah, to do a tangent line, I need a coordinate, got you, and a slope. How am I going to get the slope? Okay, what is the derivative?
What's the function?
Sweepy, you are the one that's choosing to sit way back there. So there's the function.
All right.
So derivatize that.
Gotcha. I'm on it.
I have the Jeopardy song going on in my head. Okay, yeah.
I got 1/3 x to the power of -2/3.
Can I write it like this? Can I just immediately not write the negative, but okay? Indy, I need the slope at that. How do I do that without a calculator?
That is so.
Stop mocking on my beautiful functions and numbers. Eight to the 2/3. Can I split apart that exponent?
Yeah.
Yes, I can. Is it easier to do the squared and then the 1/3, or is it better to do the 1/3 and then the squared? Make the number smaller first, do the 1/3, and then square it. Okay, gross. So it's
See,
1/3.
you
Oh,
say
shush.
it too.
I'm allowed. Because. So 1/3 times 3 times 8 to the 1/3 is 2. Squared. Is that squared on the 2 and the 3, Mikhail, or is the 2 okay, then what does this come out to be? 1 over 12. Okay. So my coordinate was 8, 2, and my slope at 8 is 112. Amalia, how do I write the equation of that tangent line, or the linearization?
Y equals 112 x minus 8 plus 2.
Okay, I'm gonna go the longer way. Y minus the y value equals slope times x minus the x value. And I'm gonna leave it like this because they're asking me use this tangent line that we now have to approximate the value here. So, Iris, how do I do this? I want to find L of 8.5, or the approximation using this tangent line. So 1/12, 8.5 minus 8 plus 2. 8.5 minus 8 is 0.5. It's also known as 1/2. So the approximation is 2 and 1/24. Yes? Ryan, you have your calculator out. What is 2 and 1/24?
2 and 1/24.
2 plus 1 over 24.
2.0412.
2.0412. Okay, I want to know, is this approximation an over or under approximation without typing the answer in? Simon, do you know what to do?
So, what's the over approximation and now feeling like, oh, because it's concave down. So that.
Okay. So he said it's concave down, so it's going to be an over approximation. How do you know it's concave down? Okay, visually looking at it, I need math. I need numbers. Okay, I would need to do the second derivative. So, I mean, I drew the graph. Do you guys know what that graph looks like? Do you know what x to the 1/3 looks like? Maybe. You should from pre-cal last year. In the middle of a test, you're going to panic and be like, hell no, I don't, no idea. So do exactly what he said, though. Check the concavity. Nick, what's the derivative of this guy right here? Multiply by the power.
Well, I got -2/9,
X to the
-5/3.
to the 5/3. And at 8, I don't need to find the actual value. I just need to know, is it bigger than 0 or less than 0? When I plug in 8, something positive is going to come out of this bit. Times the 9, it's still positive, but I've got a negative on top. So I know that second derivative's negative, which Simon said second derivative is negative, so the function is concave down. And what do the 3 dots mean? Therefore.
Oh, really?
Yep. Therefore, it's an over approximation. Hang on, Isaiah. And he also said, well, visually, over here, the tangent line's going to be on top. So, duh, it's going to be an over approximation, which, yes. But on an AP exam, they're going to want the analytical, do the stuff with the equation. What, Isaiah, was your question?
You have to do like a number line and find it on like both sides of A, or what do you got?
Okay. What you're asking about is critical points. Is 8 a critical point? Is that where the curviness No. What is a critical point? Well, what's the definition of critical point?
Where the first derivative is 0 or undefined.
Okay, where the first derivative is 0 or undefined. What is the only critical point that this function has?
0.
0. And on the first quiz that you guys did, I have still not graded the retakes, sorry. Many of you, even on your corrections, ignored that 0 is a critical point. Like, no, like, it's undefined at 0, so that is a critical point. You need to keep those in there and in the spectrum of stuff to check. Okay?
Isn't the number like 2.0 or 2 on the left? Shouldn't it only be 3?
Okay.
Or is it-
Good question. He said, this thing, you said 3 decimals, 3 decimals, 3 decimals. Keep at least 3. The AP exam doesn't matter doesn't mind usually if you keep extra, but if you do fewer, they get really mad. So as an answer, you can put in 2.041. You can keep the 2. If this was 2.0418, you can truncate, which means just cut it off, or correctly round, which is 2.042. They accept both of them. Yes.
On the delta map, you have to really keep it.
Delta math is cranky. Delta math you have to follow their directions, which is probably to properly round.
What's something?
Are you talking all the decimals or else we
Is
off
probably
by
around like
100?
6 or
Okay, Delta math. Those of you who are using, like typing in 3.14159, use the pi key. And just keep using the thing that's on your calculator, like store it or something. Well,
that's what we do. Is just sometimes like it gets picky with. I was worried about this for like the test tomorrow. It gets picky with like one of them in the homework. I put like 4.78, and instead of that it says 4.8, and it was like marked. I have to say I got no credit for it. So it's
okay, you gotta follow the directions as they're stated, and
Just like, it didn't
I am collecting homework, or not homework, the work.
Okay.
So you guys, first of all, I should have just snapshot and shown you what you guys show as work. There's like arithmetic barked all over the paper, no labels on it. I'm like, what the hell is this? So tomorrow, if you don't even let me know what problem number all of that barked arithmetic goes to, there is no way I can look for partial credit. So it is in your best interest to have a logical flow of work, and that the work for problem 1 maybe is first, and that you're telling me I found f prime, f double prime. These are my critical points because I said the first derivative. Do you need to add all those words? No, but make your work like, hang on. If f of x is 3x squared minus 6x, okay, f prime, problem number 1. If I am looking for critical points, where is it undefined? Nowhere. My one and only critical point is x equals 1. Then is it a max, a min, or a neither? Then I would have to check something else. Natalie, what?
So why are we doing the test on Delta Math?
Because it's self-graded.
Gotcha.
Tessie?
Can we like go back and forth between our answers on Delta
So there's a little thing underneath that will say like unsubmit answer, and you can enter it. You can do all of the tests and come back and check your work and be like, whoa, I did my number line wrong. Like here, I have a number line, f prime. I'm testing. Is this a max, a min, or otherwise? Putting in a 0, I get a negative. Putting in 9,000, I get a positive. And if I say that's a maximum at x equals 1, whoops, no, it's a minimum because the first derivative goes from negative to positive. Yes.
Like you just said, we're doing it because it's self-graded, but like, are you gonna look through our work to make?
Yes, I can look and see.
Is that not more work
Everyone's-
than just grading it?
No, because if there's a little green check mark, I go you.
Those like the ones that are wrong.
So I will look at them, and if there is work to support it that is easily understood, like if you got to here and you said that this is a maximum, well,
Do we get like the whole class? Or is it like?
Yes, you get the whole class.
So there's not gonna be a secret timer?
Well, there is a secret timer that's not so secret. It's like up there going, time is running.
Someone could easily miss it.
Very few people can miss that.
Very few people.
So,
Very locked in on the test.
Not appropriate.
Slight oversight.
I can do this for you as well. And it is set to be the time that there is in class, so you can see it here on in your face as well. But the timer is set to be for the class period. Walter.
Okay, so you like obviously related rates problems take a little bit of time, so you want to ballpark how many questions are on this bad boy, so like we.
For you, there's a 20
All right,
or
I knew you were
so.
gonna come back with something like that.
Yeah, Natalie.
Do we need a school Chromebook?
Yes, you need a school Chromebook. School Chromebook.
Mine is 4. Anyway, more important. So say we had done that and we had labeled that misleadingly as a maximum instead of a minimum. What sort of partial credit would that receive?
That would be wrong because
So we got almost there, like
well, okay.
95%.
All right. In the land of like difficulty, multiplying the number and lowering the exponent, not too wild and crazy. This setting it to 0 also, yes, it's a little bit of the calculus here because you had to do the derivative, but really, if you then can't interpret that and be like, the function's slope went from being negative to being positive, and you tell me, gal dang, that's a maximum, you lose points. Because gal dang, no. It doesn't do that. See, business models, when you're like, yeah, I found the best place where we're going to make the most profit, let's do this, you will be fired. Or your bridge will fall.
Okay.
And you will be fired and be responsible for killing people. Dark. My examples are always dark. Yes, Natalie.
Are you recording this?
I am. Yes. There will be a test all on corn sometime coming later. Okay. The related rates problems I think are the most difficult, and I saw a lot of you like working on these at lunch. Like, what the hell? How does this work? We did the ladders like, and we did. We started this one. Did we finish?
I don't have an answer circle.
You don't have an answer circle.
I thought we did. It was
Okay, then maybe
negative
Using calculus to find.
0.51.
I don't know. It was 1 over negative 1 over 5 pi or something. I
The
don't know.
negative 10 inches over 12.5 pi per minute times 2.
Yeah, we got unrated.
Oh,
It did B.
Because it's like, I don't know if we did A though.
Okay, so let's try A. What term would it be? Get a new notebook. All right, part A. Suggestions on how to set this up. We are talking about how fast is the level of coffee in the pot rising when the cone is 5 inches deep. I don't know that part matters. So, Roisin, what do I need to find anything in this question? What shape am I working with, first of all? Am I working with the cone or the cylinder? It says the pot. Cylinder. All right. Iris, in a cylinder, as we're dumping coffee in, does the height of the coffee change? Does the radius of no, the radius does not change. So Betsy, what is the radius given in the picture? 3. So I can, that's not changing. Nico, am I allowed to just plug the 3 in for the R? No? For the cylinder? Is it changing or not? Radius of, okay. Right. And yesterday we talked about this one. the radius of the coffee in a cone does change as the height changes. But in a cylinder, it's gonna be 3, it's gonna be 3, it's gonna be 3, it doesn't change. So in my cylinder in this problem, my volume is 9 pi times the height, right? Okay, so keep doing the derivative of this. What is the change in volume? What is dV of the cylinder? dt. Where are you getting the 2 from? Careful. I was told I'm allowed to plug in 3 for the radius because it's not changing. So it's not going to be, I don't need to multiply by the power on this one. We're doing the derivative of, now that we've swapped out R for its number value, what's the derivative of 9 pi h with respect to time? 9 pi dh dt. Did this, right, did I need this at all in this part of the problem? When the height of the coffee in the cone is 5 inches deep, jerks, they gave me extra information there that I needed for part B, but I didn't need it in part A. Eric, do I know dV dt? Did they give that to me in front?
dV
Yeah,
T of the cylinder of the cone.
it's the same. Why is it the same? Okay,
Okay.
the coffee going, technically, if you want to do the Duncan Crane physics thing, well, some of the coffee's going to get stuck in the filter, so a little bit of it's going to get, yeah, okay. Assume there is no coffee filter issues. The amount going out of the cylinder cone is going into the cylinder. So what is the change in volume?
The same.
So it's going to be 10. And Carson said the only difference is it's negative for the cone because it's leaving, and it's positive for the cylinder because it's going in. So right here, and the units are what are the units on this?
Inches cubed.
Okay. It's not inches cubed anymore. Like height, what's the dimensions for height? Inches, miles, feet, what is it going to be? In the problem, it gave us, you're right, it gave us the change in volume was inches cubed per minute, but height is just inches, the time's still minutes. How come inches cubed per minute became just inches per? What were the dimensions of this radius? Weren't they inches as well? So that was inches squared, and this is my third inches. Okay. All right. On that sheet, what other of those problems look most horrible to do? 29. That the biker and the balloon and the. Oh, the dude, he does suck. Okay. Can anyone draw it?
No.
No, you can't draw a triangle? You wanna try?
I can't draw, but I'll try.
Okay, here you go.
I feel like draw a straight line.
Well, if you want, you can be all fancy,
Like not
and
really.
there you go. That'll make them all straight lines, so don't try and put letters.
All right.
See, Walter?
Okay, so the street. I'll do street light first, I guess. Ooh. So that's.
Do I have to do it like this? Miss Pascal?
You can turn it off if you want.
All right. So this is 16 feet, right?
You have it in the line side.
How do I turn it off?
No, it's not. I tried to turn it off and I did that, Eric. So that's not off.
Okay, it's off.
It's on.
But what is his shadow?
Wait, what's square?
Okay, so that's 16. And then 6 feet. What? I guess like he's walking 5 feet this way, right?
Shadow is changing when it's 10 feet on the face.
Oh, this is 10. I know, but it's changing by 5 feet
Yeah.
a second. That's what it's saying, the derivative. Right?
DX, where you could do whatever. She's shorter.
dx dt equals 5. If he's walking towards it, would be negative, right?
Yeah.
Feet a second. And then like this is his shadow would be this bad boy, the hypotenuse, right? That guy. So that we don't know that.
No, this is not it, man.
What?
Do a quick 180.
What?
See, you act like I was like gonna get that.
Alright, no,
It
come on.
wasn't easy though.
Okay, so
And I wasn't far.
I don't disagree with your picture, but I'm gonna make it cleaner.
You
Is
just
that
have to
right?
add the 6 there.
Alright,
Nothing.
I need.
We all make mistakes.
I didn't actually technically make a mistake. I left out.
Yeah.
I left out a couple things.
So you didn't get it right.
I
Right.
left out.
So
You didn't get it right.
triangle and shadows on the ground. They don't float. The shadows on the ground. 6 foot tall dude and a 16 foot tall lamp thing. And do shadows float? Where do you see shadows?
Doesn't the shadow move with him?
Okay, the shadow will shrink, but does the shadow go along the ground?
Yeah.
Yeah, okay.
Where's the
how do you
end
know
of
where
your,
the
what are you using at the end of that triangle on the far right? How do we know what that is?
That is his shadow. So,
it's 6 feet.
so you got to think about it. When you are under a street light, as you walk towards the street light, is your shadow getting longer or smaller? And is it in front of you towards the light, or is it behind you?
Yeah, I forgot.
What if it's broad daylight?
If it's broad daylight, then that's not gonna work, people. This is nighttime. He's on a walk,
What if we
and
get a
he's
problem like
scared,
that
so
and we
he's
just
going
don't
to the
know, like,
lights.
the thing that's the Well, I just don't know.
I don't
Okay.
think I should start.
He is 10 feet from the base. Do I know the length of the shadow?
No.
And I would normally
Oh,
call
actually,
the
yes, you
shadow
do.
length S for shadow, but
10
my
minus.
S's look like 5s. So I'm gonna just call it X. Is that okay? Walter, what were you saying?
Well, is the whole thing, I mean, if he's 10 feet away, at first I thought it was 10 minus X, but that doesn't make sense because they're going together, so I don't think that makes sense. I take back what I was gonna say. But like, we've done that on like a previous problem, if you know what I mean? Like,
Isn't this triangle moving?
It's a similar triangle. So you can find X.
oh, so it is 10 minus.
No. So hold on.
So much.
Carmen is saying these triangles are similar because go geometry. These triangles, like unless the lamp is like tilted in Picasso lamp post, and unless the dude is like walking kind of slanted, I mean he's gonna be walking with a right angle. And then by reflexive property, this angle is equal to itself. So 2 angles of one triangle equal to 2 angles of another. They're similar, and mathematically that means what, Carmen?
So you can set 16 over 10 plus X equals 6 over X. Cross multiply.
Okay, hold on. So hold on, just to explain this, she says in this bigger triangle, this length to this whole length, 16 to 10 plus X, has to have the same ratio as the littler triangle of 6 to just X. All right, hang on. Are you guys okay with that setup? So all of this is just one variable in it. Eric, what were you gonna
Is
ask?
the ratio still true if it's L over 16 equals L minus 10 over 6? Like, can you have the,
Yes? But
that
you
is
need
true
to-
too.
Yeah. Yours is gonna be harder to solve because of this last piece of information. What is the only rate that we know? The, his distance walking forward is 5 feet per second. Negative. So what is changing in 5 feet per second? Like, does that mean the shadow is changing at 5
Oh,
feet per
it's
second?
the length of X from theta.
The length of X from the lamp post. But, all right, so Carmen was saying to finish this, she cross multiplied and got 16x equals, you okay that I distribute the 60 plus 6x, subtract that. Well, goodness, all these things, x goes down to 6. But I needed to do something first. I need to somehow have these rates relate to each other. I need to do the derivative of something.
We're just assuming we can find the value of X.
We did. We just did.
You can find the hypotenuse using.
Okay. Is this thing always 10 or is it changing also? It's changing also. So do I need a letter for that also?
Sure, yeah.
D? Oh no, can't use D.
L.
Why?
All right, we'll call it L. Because L is changing. And so I don't know if the shadow length is changing at the same rate as his distance from the pole. That's what we've got to check out. Do I know? Well, L, I was told at this snapshot in time is 10. Do I know dx dt? That's what I'm looking for. So I don't know that. But do I know?
Wait, you do know
Negative.
I
You
know
don't know the XTC, but you do know DLDT.
the LDT. He's walking 5 feet per second closer. Yes.
No, because the man is at X, not at L. The lamppost is at L.
He's walking this way at 5 feet per second. What is changing at 5 feet per second? Is it this distance of L or is it this distance of the shadow?
From theta, it's
From,
X.
there is no theta. From
The
here,
angle.
he's walking this way. This distance L is the thing that's changing.
Why? Wouldn't they both change?
They're both going to change, but this is the rate they told him. He's walking. He is walking.
So is L just the difference between the man and the lamppost, not
Yes.
the distance between
Yes.
everything?
Yes.
Okay.
So, okay, through all this, this was true, but in here, what do I need to change to take into account that the distance to the pole is also changing? Is the 16 changing? Is the height of the lamppost changing? Is the height of the dude changing? And X is the length of the shadow. So the thing that we need to swap out, 10 isn't always 10. It's changing also. So we're still gonna do what Carmen said, cross multiply. So 10x equals 6L. Abby, what is the derivative of this little equation with respect to time?
10 dx dt equals 6 dl dt.
And I was looking for dx dt. Divided by that 10, do I know dl dt?
Negative 5.
So it looks like -3. What are the units?
Feet per second.
Feet per second. So the shadow is getting smaller by 3 feet per second as he's walking forward at 5 feet per second. They weren't the same. Carson doesn't like that answer.
The answer's problem.
The answer. Any question? Yeah.
Wait, sorry, I got lost in what you did last. So I understood where you were at 10 dx over dt equals 6 dl over dt. And then
Okay, so let's use
oh, you
colors.
just divided it and then
So here I divided by the 10, and then I plugged in the value that I was told.
okay, so dl.
Isaiah, which one are you talking about? You did issues with a different one?
Just got
Someone else asked about 21. Natalie, was that you? I don't think so.
Yeah, with Tessie.
Tessie, you said 21?
Yeah.
I like the balloon one. Nobody asked that.
Did we do
Didn't we? Yeah.
We didn't do that balloon one. All right. This problem, there's a boat being pulled in to a dock, and the dock is 6 feet above the boat, and the rope is being hauled in at a rate of 2 feet per second. How fast is the boat approaching the dock? When there's 10 feet of rope moving out. Okay. Is there anything static and stable in this? Like, yeah?
The height of the dock.
The height. This 6 is always 6. It's not changing. Because we're evidently going to haul that boat in before the tide changes. So we get to assume this stays as a 6. Is the length of the rope changing?
Yes.
Yes. Okay. So I have R and the RDT. Did they tell me, let's see,
We have the RDT.
when 10 feet of rope is out, is that this distance is 10 or is it the hypotenuse is 10? The hypotenuse is 10, but the rope is also changing. That's what, the rope is being hauled in at 2 feet per second. Is it a +2 or a -2? -2 because you're pulling it in, so the rope is getting shorter and shorter. So -2. When this little snapshot happened, Lanham, do I know how far away the boat is from the dock? I'm not told, but can I calculate it
Yeah, you
using
can use it, but
Pythagorean theorem? So this is 6, that's 10. What is this one going to be? 8, because you guys have seen this a lot. Or you do 6 squared plus x squared equals 10 squared. Good. Do I know dx dt? That's what we're looking for. How fast is the boat approaching the dock? Okay, Mikhail, what equation do I set up that uses these things?
Not sure.
Okay. I'm looking like I need these 3 lengths. What? Yes. X squared plus y squared equals z squared. We've done a few of these now. 2x dx dt plus 2y dy dt equals 2z dz dt. You don't need to, but I like making things smaller. I'm going to divide everybody by 2. What was dy dt again? 0. So this becomes x dx dt, because this was 0, z dz dt. Carson, what information do I know that I can just plug into this? Do I know x?
Yeah.
I calculated it, I got 8. Do I know dx dt?
No.
No, that's what we're looking for. Do I know z? Or I should call it r because it's the rope.
Yes.
What is it?
10.
At this snapshot in time, it's 10. And what is dz dt?
-2.
Okay, so it's negative 20 over 8. Ray, what is the units?
Feet per second.
Feet per second,
Just moving.
because it's changing. Yep, okay. And we can reduce that. The boat's getting closer at 2.5 feet per second when the rope was getting shorter by 2 feet per second. They don't have to be the same. All right, Nico, the part B of this is like asking us about that angle, and the angle's drawn here. What equation, so it's not going to be Pythagorean theorem, what equation can I use to tie together that angle with the lengths? Yeah.
I'm not sure.
Asher?
You could do sine theta equals 8 over 10.
Okay. I could use sine theta is 8 over 10. Yes, Walter?
Use any of them.
You could use any of them, and one of them is,
One of them is 0.
yeah, okay. So one of those 3 trig functions is less desirable. Which one? Tangent? No, tangent is fine. Cosine is fine. The one that's poopy is the one that was chosen. Why is sine less desirable? Because sine, this side is changing over time. This side is changing over time. Use the one that has the static value. So I recommend cosine theta is 6 over r. Like the 6 is still 6. We're not taking into account the tide changing. All right, guys, please do the delta math. Check it out. Finish it by tomorrow because it's going in the grade book. That is what your test is on. Bring your own calculator. And Eric, what kind of computer are you going to take the test on? A school Chromebook. I'm scared. A school Chromebook. Yes.
I'm trying to